Hey guys, today we're going to learn about the last new thing in your packet. You've reached the end. This thing we're going to talk about today is called colligative properties, and it has to do with solutions, like when you mix salt and water together. So remember that the salt and the water have special names. One of them is the solute and one of them is the solvent. So in case you forgot the difference between those, we're going to review it really quick. The solute is the substance being dissolved, and the solvent is the substance doing the dissolving. So usually what this is like salt or sugar could be a solute, and water is the universal solvent. But now something special happens down on the molecular level when we mix salt and water together. So when a solute is added to a solution, it does something called dissociates. It splits into ions. So it splits into pieces. It doesn't stay salt. It splits apart into pieces. And that makes the solution do a couple of funny things. There are two things that it can cause. So you could get what's called freezing point depression. What that means is the freezing point lowers. So water normally has a freezing point of 0 degrees Celsius, but when I do this and I put salt in it, it might go down to -5 or -10 degrees Celsius. It goes lower than it normally should. The reason why is really important. The solute particles, now the solute particles are the little salt ions, because they've split apart at this point, they interfere with the intermolecular forces of the solvent. It's basically like they kind of get in the way of everything. So here's what's going on. The salt ions that are in there are going to get in the way of the water molecules freezing and turning into crystals. So I'm going to show you what that looks like, because that sounds kind of funny. Here's some liquid water, right? When you have water as a liquid, the particles are kind of touching, but they're not super on top of each other. They're just kind of nearby. When they freeze normally, they would stack up and they would get really close. Remember that remember that ice, when it becomes a solid, the molecules get really, really close together. Okay? But here's what happens if I have liquid water and then I put a bunch of salt in the way. So this is the salt splitting. Notice that it's NAs and CLs separate, right? That's dissociation. They've split into pieces. So now this water molecule can't get as close to the other water molecule because there's all these ions bumping around in the way. So it'll eventually happen, but with all of those extra things in the way, the water molecules can't get as close as they would like to, or what they would normally do. There's all these extra ions in the way, and so it's going to take longer at a lower temperature to freeze. The second thing that can happen is the opposite. It's called boiling point elevation. Elevation means that the boiling point is going to rise. So where normal water boils at 100 degrees Celsius, if you put some salt into it, then it might boil at 110 or 120 degrees Celsius. It's going to be higher than normal. Again, the reason why is really important, but it's kind of similar. The ions are basically in the way. The salt ions get in the way of the water molecules boiling to the surface. They want to escape as a water vapor, but the salt ions are in there and kind of block their way out. So again, here's my liquid water molecules, right? They're kind of close. What normally would happen is they would kind of bounce up, and remember, a gas becomes very spread out. So they would leave the surface of the water and they would evaporate and become very far spread apart from each other. That's how gas works. But if I dissociate a bunch of salt, so we've got these ions split in half. So there's my dissociated salt. It's much harder for this water to break through the surface because that Na is in the way. So it's almost like the water has to find a way to bounce around or bounce through before it can escape and become a water vapor. Okay, so same thing, maybe this water molecule is ready to boil, but there's some salt ions holding it back, and so it's much more difficult for it to escape and become water vapor. Again, it'll still happen, it's just going to be at a higher temperature. So, you have a more effective solute it will break apart or dissociate into more ions. So the trick here is it's more effective if you have more ions. More effective means that it will basically make the freezing point, FP, more effective means the freezing point will be lower or the boiling point will be higher. So it's almost like it's better at disrupting the freezing and boiling point with more ions. So we need to practice counting ions so that we can identify which ones are more effective. So we've got some examples here. And the first question to ask yourself is, well, which of these things are actually even ionic, right? You will know that something is ionic if you see a metal and a nonmetal. Or you might also see the presence of any polyatomic ions. So let's look for those things. This one is ionic because calcium is a metal and we have a polyatomic ion. This one is also ionic because sodium is a metal and chlorine is a nonmetal. This one is ionic because we have a metal, calcium, and a nonmetal, nitrogen. This one is ionic because we have a metal, potassium, and oxygen, a nonmetal. This one is ionic because it has sodium, a metal, and NO3 is a polyatomic ion. This one is not ionic because it's all nonmetals. What that means is it will not dissociate at all. It will stay one big giant molecule and it will not break apart, which means it won't be as good as the ionic solutes. So this one isn't even going to break apart at all. It's not going to dissociate because it's covalent. So now let's see if we can compare and count the ions. Oops. Let's see if we can count the ions for the ionic things that we have. Okay. So the ions that I have in the first one, in Ca3P, this 3 refers to the Cas, so I have 3 Ca ions. Okay. I also have PO4. That whole thing is one ion, and because of this 2, I have 2 of them. That's a -3 charge. So if I have 3 of these calcium ions and 2 of these PO4 ions, altogether this thing has 5 ions. Okay, let's try another one. The cation ion here, the positive one, is I have Na. Since it doesn't have a subscript, there's only one of those. The anion, if you want to put the ion, it's a +1. The anion is chlorine. It's a -1 charge. Again, there's only one of those. So one of these and one of these. This one has 2 ions. So if I just stopped and compared those two, this calcium phosphate is a more effective freezing point depressor and boiling point elevator because it has more ions. So this would affect the temperatures more compared to NaCl. Let's look at some of the other ones and see if any of them would have a greater effect. Okay. If I look at Ca3N, I've got 3 of the calcium ions because of this. I've also got a nitrogen ion, which is a -3 charge, but there's only one of those. Okay, so if I have 3 of these and 1 of these, altogether I have 4 ions. Okay, so this one is still better than the NaCl, but not quite as good as the calcium phosphate, the Ca3PO42. Let's try the next one. I have 2 of the potassium ions, that distributes there. Because there's nothing written on the O, I've got 1 of those. So altogether, I have 2 potassiums, 1 oxygen. That gives me a total of 3 ions. Okay. Let's try the last one. I have 1 sodium ion, an Na+1. There's nothing there, so it's a secret 1 hidden. The trick is for polyatomic ions, they are one whole chunk together. Don't split them up. So that whole NO3 thing is 1 ion. Since there's no other number there, it means I only have 1 of those as well. So I have 1 sodium and 1 nitrate ion. That one only has 2 ions. So of all the possible ones in our list, this first one, the calcium phosphate, has the most ions, so it would be the most effective. It would change the freezing point and boiling point the most. So now you've got some questions on the bottom. Go ahead, see if you can answer these, and then I will show you the answers. Okay, so answers for these questions, you should have had this, and the last one is B. But now if you struggled with any of these, then come and talk to me and we will figure out why. Good luck!